In the previous video for exercise 125, we saw how combinations of atoms and lone pairs, certain combinations, will lead to certain shapes. And so we talked about 5 shapes in particular that you'd want to be familiar with. These top 3 tend to be the shapes that carbon has, though other things have those shapes too, and carbon has other shapes. This fourth one, trigonal pyramidal, tends to be the shape nitrogen takes on, and this last one tends to be a shape oxygen will take on. So that's just a rule of thumb. But since those are the major players in organic chemistry, we want to be able to visualize what type of shapes they are, those atoms are creating when they come together to form a molecule. With the significance of that being all of those shapes add up to little ridges, and the ridges will either fit or will either let the molecule fit or not into different receptor sites. So this question is asking you to predict the geometry around all of the atoms except for hydrogen. So we're just going to do this one atom at a time. So let's start with this carbon right here. How many bonds or how many atoms is that carbon bonded to? 1, 2, 3, and 4. So that is going to be 4 atoms around there. And how many lone pairs are around this carbon? We don't see any dots, so there are 0 lone pairs there. And for lone pairs, sometimes you may see that abbreviated as LP, capital LP, so lone pairs. So 4 atoms, 0 lone pairs, that means that the shape around that carbon is going to be tetrahedral. So this carbon will be tetrahedral. Oops. Okay, let's go to the next atom. The next atom is this nitrogen right here. So how many atoms is that bonded to? Well, it's bonded to 1, 2, 3 other atoms. So we're looking at 3 atoms. How many lone pairs? 1 lone pair. 1 pair of dots there. So 1 lone pair. And if we compare that with that table that we walked through in the previous problem, we can see that 3 atoms and 1 lone pair is trigonal pyramidal. So it looks like a pyramid with a triangular base. So that part of this molecule would be trigonal pyramidal. Okay, let's move on around this ring. Let's go to this carbon on the right. So this carbon here. How many atoms is that carbon bonded to? It is bonded to 1, 2, 3, and 4 atoms. So it's bonded to 4 atoms. And how many lone pairs does it have? If you look, you'll see there are no dots around that carbon, and so there are 0 lone pairs. And so the combination of those two things, when all those things push against each other, 4 atoms and 0 lone pairs, you get a tetrahedral shape. So that carbon is going to be tetrahedral. How about the next carbon up? This one here. So how many atoms is that bonded to? 1, 2, 3, 4. That is bonded to 4 atoms. And if you look, there are no dots around that carbon, so it has 0 lone pairs. And the combination of 4 atoms and 0 lone pairs is tetrahedral, as we can see in our little table that you would want to have in your memory. So you wouldn't be able to use any notes on an exam. You would have this table memorized. So 0 lone pairs, 4 atoms. That's tetrahedral. How about this oxygen here? So that oxygen, first question, how many atoms is it bonded to? It is bonded to 2 atoms. So it's bonded to 2 atoms, and how many lone pairs does it have? It has, there's 1 lone pair, there's 2 lone pairs, it has 2 lone pairs. So 2 atoms, 2 lone pairs, when all those push against each other, what shape does that give you? It gives you a bent shape. And so that there will be bent. Now, if something is not on that table, then you would not be asked about it, so you could ignore it. So this oxygen, for example, if you were to think about that one, that is bonded to just 1 atom, and it has 2 lone pairs. So 1 atom and 2 lone pairs. That is not one of the shapes that you would be expected to know. And also, since it's in order to form a coherent shape, an atom has to be bonded to at least 2 other things to have a molecular geometry. So that you wouldn't have to give a name for that. You wouldn't be asked about, so don't worry about that one. How about this next carbon here? That carbon is bonded to how many atoms? It's bonded to, and actually let me just erase these to make everything clearer. Okay, so this is bonded to 1, 2, 3, 4 atoms. So 4 atoms, how many lone pairs around that carbon? There are no dots around that carbon, so 0 lone pairs. And so that combination of 4 atoms and 0 lone pairs gives us a tetrahedral shape. So that carbon is going to have a tetrahedral shape around it. How about the last atom in this particular molecule that we haven't considered? This carbon right here. And so that carbon, how many atoms is it bonded to? It is bonded to 1, 2, 3, and 4 atoms. So we're looking at 4 atoms. How many lone pairs? If you look at that carbon, there are no dots around there, so 0 lone pairs. And that combination of stuff pushing against each other, 4 atoms, 0 lone pairs, is tetrahedral. So the shape around that carbon will be tetrahedral. And so that's the geometry around all the atoms except hydrogen in our first compound, compound A. It was so much fun. Let's do it for another compound, compound B here. So let's start at the bottom, carbon. How many atoms is that bonded to? 1, 2, 3. So we're looking at 3 atoms here. And how many lone pairs are around it? Look around that carbon, there are no dots, so there's going to be 0 lone pairs. And when that type and amount of stuff push against each other, the shape that it ends up with is 3 atoms, 0 lone pairs, trigonal planar. So it's going to look like a flat triangle. Oops. So this will be trigonal planar. Okay, how about this next carbon? How many atoms is it bonded to? 1, 2, 3, 4. So it's bonded to 4 atoms. How many lone pairs are around that carbon? Looking around the carbon, we don't see any dots, so there are 0 lone pairs. That amount and type of stuff pushing against each other gives you a tetrahedral shape. So the shape around that carbon will be tetrahedral. How about this carbon right here? Well, first thing we want to think about, how many atoms are bonded to that carbon? 1, 2, 3, and 4. So we're looking at 4 atoms. And how many lone pairs around that carbon? There are no dots there, so that's going to be 0 lone pairs. So that combination of stuff pushing against each other gives you a tetrahedral shape. So that the shape around that carbon will be tetrahedral. Okay, how about this nitrogen? What shape would be around that nitrogen? Well, first, let's ask how many atoms is that bonded to? 1, 2, 3. So we're looking at 3 atoms pushing against each other. How many lone pairs pushing against each other? Well, there we've got just one lone pair. And so the shape around that nitrogen will be, when all those things push against each other, you get that triangular pyramid, the pyramid with a triangular base, trigonal pyramidal. So the shape around that nitrogen is trigonal pyramidal. How about the oxygen? This oxygen right here, what shape would that have? First, how many atoms is it bonded to? It's bonded to 1, 2 atoms. How many lone pairs are around the oxygen? 1, 2. So we've got 2 atoms around it, 2 lone pairs around the oxygen. And so the shape of that oxygen will be the shape that results when all those things push against each other, and that is bent. Looks a little bit like a V, so that will be bent. All right, moving around the molecule, we've got a carbon here. Let's see if we can figure out what shape that has. That carbon is bonded to 1, 2, 3 other atoms. So 3 atoms. And if you look around that carbon, there are no dots, so 0 lone pairs. So the shape around that carbon is the shape that you get when 3 atoms and 0 lone pairs push against each other, and that is trigonal planar. So trigonal planar looks like a triangle that's flat, planar. Okay. How about this carbon up? Or actually, before we get there, let's make a note about this nitrogen. If we follow the same procedure here, we'll have that nitrogen is bonded to 1, 2 other atoms. 2 atoms. And around it, you have 1 lone pair. Now, if you go to this table, you won't see that combination there. It turns out that that ends up being bent, but you don't have to know it. If it's not in that table, you don't have to know it. Just so you can see how it's bent. If you have a central atom and it's bonded to 2 atoms, and you've got a lone pair, you can see how it has that V bent shape. And you can see at the bottom left of the screen, it gives you the molecular geometry of bent. So, but because it's not on that table, you wouldn't have to worry about it for this test. So the next thing is you've got this carbon here. How many atoms is that bonded to? 1, 2, 3, 4. So we're looking at 4 atoms. How many lone pairs on that carbon? There are no dots there, so 0 lone pairs. And so that carbon will have the shape that you get when 4 atoms and 0 lone pairs push against each other, and that is tetrahedral. So that carbon will have a tetrahedral shape around it. All right. Next on this carbon here, how many atoms is that bonded to? 1, 2, 3, and 4. So that's 4 atoms. How many lone pairs around that? There are no dots around that carbon, so 0 lone pairs. And the combination, the shape you get is the shape that you get when that combination of stuff pushes against each other. 4 atoms, 0 lone pairs, that's tetrahedral. That's the shape around that carbon. Last but not least, this carbon here. How many atoms is that bonded to? It's bonded to 1, 2, 3 other atoms. So 3 atoms. How many lone pairs? there are 0 dots around that carbon, so 0 lone pairs. And the combination you get of that stuff leads you to a shape that is 3 atoms, 0 lone pairs, trigonal planar. So triangular and flat. Trigonal planar. So you see how those individual shapes can repeat or vary throughout a whole molecule. Look at all these different shapes we've got. And those simple shapes, those 5 simple shapes, can add up to a molecular shape that's really subtle and involved and can fit into only a very particular pocket, very particular receptor site. All right, last but not least, somewhat smaller molecule. Maybe in this one, because we've done so much practice, we can see a pattern. So if you notice, actually, every carbon in this molecule, and we'll just use this one as an example, but every carbon in this molecule is in the same case. It's bonded to 1, 2, 3 other atoms. So 3 atoms. And it doesn't have any dots, so 0 lone pairs. Now, we've seen when that combination of stuff comes around a central atom, 3 atoms, 0 lone pairs, it is trigonal planar. So, for example, just to visualize that, if you have 3 atoms and 0 lone pairs, you get this trigonal planar shape. It's flat, but then it also looks kind of like a triangle. So trigonal planar. And if you notice, that's the case for every single one of these every single one of these carbons. So this carbon here is bonded to 3 atoms and doesn't have any lone pairs. This carbon here is bonded to 3 atoms and doesn't have any lone pairs. This carbon here is bonded to 3 atoms and doesn't have any lone pairs around it. And you could go through each of the carbons and see that around all of them you have this pattern. So if every single one of these carbons is flat, this whole molecule is going to be flat or planar. And so here we see the repetition of just one shape giving us a very special shape to the overall molecule.